Watch your back, browser, you're being observed. Let me quickly introduce myself. I'm Stefan. Sometimes I run around like that because we do something that is called onesie.js, which is a lot of fun. So if you want to have a lot of fun at an event, just put on this and make a lot of new friends. I'm also a front-end person, so that's all crazy stuff that Adrian told you. I'm teaching occasionally CSS at Node, and I'm organizing the Web Performance Meetup in Berlin. Yeah, and I like web performance, accessibility, and open source. And I work for this company, which is called Contentful, which is basically a content infrastructure in the cloud. We're an API-first service, means when you don't want to set up your own CMS because you are a front-end person like me, and you just need an interface where people can edit stuff, and you want to deal with an API, you can give Contentful a try. And what we always say is that with Contentful, editors get a CMS, and developers don't actually have to work with one. And this is a lovely event so far, but I also care a lot about really, really great events. And what I want just to tell you, or show you, is the Global Diversity CFP Day, which is on the 3rd of February, which is a worldwide workshop where speakers and event organizers come together to show and teach beginners how to give a proper talk. So maybe we can bring in some new speakers for future events. And the last thing is that I'm actually really excited about these events, because you can learn so much stuff, and you meet new people, you make new friends, you can have an excellent time. And these events help me to stay up to date. And the web platform evolves really, really fast these days. We've got finally yearly ECMAScript releases. I think that is awesome. New browser APIs are coming out every day, and we finally have evergreen browsers. We're living at a good time, but still, staying up to date is kind of part of our job, right? And I personally have a hate-love relationship with this. Because, well, who here works with front-end stuff? This is what we're dealing with, right? A new tool every week. But at the same time, changes are happening. Browsers are finally adapting common use cases. And think of jQuery, right? Today we have document query select all and all these kind of things. But there's also movement happening, because usually what we had to deal with was the pull model, and browsers are slowly adapting a so-called push model. And what I want to show you in the next, if I'm not running over time here, in the next 20 minutes, is what that actually means. And I want to do that with a little bit of celebration, because we have a lot of cool new stuff today. So what I did is I took the Hack Junction or Hack Talks website. This is how it looks like. And I thought, well, maybe we want to spice that up a little bit. So what I did first was I implemented a typical lazy loading effect into the schedule, right? And what you see there is the Twitter heart animation, which is done by Anna Tudor in this case. So if you want to see really crazy advanced CSS, just check out Anna Tudor. And how would you usually approach that? Well, what I did for years was Googling how to check if an element is visible, right? This is what you find. Stack Overflow question, guilty of copying this 100 times probably. There's one problem with this though. This little function, getBoundingClientRect, can trigger the browser to synchronously calculate style and layout. This means that this can actually cause work in the browser. This happens when something has changed, like a new class is there or something. So when you use that, you should follow best practices and batch all the reads and batch all the writes. But this is actually not what I want to do, because this is pulling for information. If you're interested, or if you want to check what browser operations are actually really expensive, Paul Irish is maintaining this document, so check that out. So now we have this function. So what do I do next? I define a scroll handler, right? And check if the elements are visible, and if not, I'm adding a class that is called party here, which then triggers the effect. And then I'm removing the elements from the array because the work is done. But then again, scroll handler, you should throttle scroll handlers anyways, because, well, how much time do we actually have when we want to build great user interfaces that stick under our fingers? Well, the goal is 60 frames per second, which means 1 second divided by 60, 16 milliseconds to have this great experience, right under my finger. But this is actually not true, because, well, the browser has to do some other stuff than to deal with our code, which means that we end up with probably 10 milliseconds for our custom JavaScript. This means that we want to do as less as possible in a scroll handler. So what I did first is I monitored the whole thing. Here we have it. And I work in tech, right? I'm here with a MacBook Pro, where I paid so much money for that, and I don't even want to think about that. So I throttled the CPU, because this device is not your user. This is me, but spending too much money. So, and then I checked, and I found out, well, the frame rate is actually 9 frames per second. And this is not completely fair, because this is not all the code I showed you, because there's a lot of stuff going on the side. But when you look at the trace here, you see that get bounding client rect is already taking 5 milliseconds. That's 50% of the whole budget that we have to have this butter smooth experience. And this happens on every scrolling frame. So maybe we can do better. Let's enter the first observer here. The intersection observer is a method to asynchronously query the position of an element with respect to other elements and the global viewport. With this, you don't have to use costly DOM queries or style queries, and you don't have to poll for information. This can reduce CPU, GPU, and energy costs to figure out if something is visible. So how can you use an intersection observer? So this is a normal intersection observer implementation. So you define an options object, which defines a threshold. With this, you can say, hey, please tell me when something is visible or partly visible or enters the viewport. And 1.0 here in this case means when it's completely visible. Then you initialize the new intersection observer. Then you got some entries there. And then you've got this is intersecting property, which tells you, well, this element is intersecting the viewport, cool. And then I'm adding the class party, and then I'm just telling unobserve. And then I'm just grabbing all the elements I care about, and I tell the intersection observer, all right, cool, can you please watch out for that? Sweet. So with this, I don't have to poll for information, and this just happens when something enters the viewport. This is a lot less work for me, and this is way more performant at the end. So what I want to tell you is when you're dealing with these kind of things, measure it, right? DevTools are extremely powerful today. And we have several tools out there, and always try, oh, my phone is over there, but always try with your phone. And maybe you don't have an expensive phone, like maybe you have, let's say, maybe you have a cheap phone available. And what options do you have for an intersection observer? Well, you can define a different root element. You can give some layout information. And then you have this threshold value, which can be a single value or an array of values. And this is actually interesting. So let's have a look. With these two values at the threshold, this will actually fire 4 times. This will fire when a pixel enters the screen, then it will fire when the whole element is visible, then it will fire when the first pixel moves the screen, and then when it's gone. Now think of your interfaces. This can be extremely cool stuff. So let's have another look at the threshold value. So threshold value 0, when does this fire? So the element enters the screen, and now we've got an intersection entry, so-called, and now we have is intersecting true, and an intersection ratio, which is something around 0. Why something? Because the whole thing works asynchronously. The browser fires that when there is time. And when this leaves the viewport again, we've got is intersecting false, which makes sense, and 0, which also kind of makes sense, because there cannot be a ratio below 0. But then there was also something that kind of surprised me initially, which was when you have a value that is greater than 0, so we again have is intersecting true, and an intersection ratio again something around 0.5. But when this leaves, then is intersecting is still true, and my head was kind of like, shouldn't that be falsy right now? But actually, this also makes sense, because when the threshold is hit, the element is still intersecting with the viewport. And then again, a value around 0.5. So with something like the intersection observer, interfaces like that are really easy to build. Just show something when something disappears, right? This is 10 lines of JavaScript without Googling and copy and pasting from Stack Overflow. And also, you can kind of check the intersection observer to figure out if something is visible in your responsive web design. So what you see there is that the intersection observer fires and tells you, all right, is it intersecting or not? Maybe you have some use cases when you build advanced interfaces. So what is the support today for the intersection observer? Well, it's actually not that bad. There's one thing, though. When I started digging the intersection observer, I found out that there have been incompatibilities between spec and browser vendor implementations, so that, yeah, it was a little bit dangerous. But these are resolved since October 16 and one certain release. And so we're good there. And can you use that in production today? Yes, this is polyfillable, and there's an official polyfiller out there, which is maintained by the WICG. So that is really cool. So maybe you want to give that a try. So what we did so far is we celebrate every talk on its own. But I think we can do better. So let's celebrate the whole schedule. Wait a second. Yeah. All right. So that's really cool. So, but how could I deal with that now? The intersection observer code was wrapped in an immediately invoked function expression, and I have no clue and no idea how to figure out when this effect happened. So, there's also the mutation observer. So how does that work? So a mutation observer, this is the implementation for a mutation observer. So what I did first is I grabbed a list, then I figured out, all right, how many speakers are in there. Then I'm defining a config, and I'm saying I want to watch out for attribute changes, and I want to watch the whole subtree. Then I'm setting up a normal counter, and then I'm initializing a new mutation observer. Then I get several mutations, and then I'm just checking, okay, what did change here? Was it a class change or an attribute change? And then I'm counting up, and then you see this Cornify add. So if you want to add unicorns somewhere, that's Cornify.js. Takes you 2 minutes to make that. And then just observing the whole list. And this way I can watch out for DOM changes, which can be really handy in some situations. So what options do we have? We can define if we want to watch out for targets, for attribute changes, and if we want to watch the whole subtree. And there are more options. So what is the support for the mutation observer today? Better or worse? Pretty green. I said, you might not need that very often, but when you run into the situation to watch out for DOM changes, this is really, really handy. When you implement stuff like Cornify.js, though, what I want to tell you is, let's always watch out for performance, right? So what ways do we have to measure performance today? So there are 2 ways, basically. There's symptotic monitoring, which kind of means that you have a robot in the cloud that visits your site and gives you some values, or you have real user monitoring, which means that you have some JavaScript running in your site, which you then ping back to a monitoring service to do some analysis. So what I want to show you here just quickly is web page test, which is one of the most useful synthetic monitoring tools here. So what you do there is you define a connection speed, a location from where you want to test, a browser, and then you just fire it up. And what you can then get back is waterfalls, advice, requests, and all this stuff that happens. If you every once in a while see these videos where 2 websites are running next to each other, and it's compared how fast they load, this is web page test. So this is really, really cool. But this is just checking the performance at one given moment in time. So there are also tools out there that track performance over a certain amount of time, because actually you want to track how you're doing, right? If you do worse, then you want to get an alert or something. So there's speed curve and caliber. But what I actually want to talk about right now is real user monitoring. So how can we get the performance metrics out of the browser of our users? So there's the navigation timing API, the resource timing API, and the user timing API. So let's have a quick look here. Window.performance.timing is an interface for web applications to access the complete timing information for a navigation of a document. And this is a lot of information, right? This is your initial HTML call. This can be extremely valuable to see how you're doing with your web performance stuff. So there's DNS in there, there's TCP in there, and even DOM content load. Maybe you want to know that. And then there's also the resource timing API, which is available via window.performance get entries by type resource. And this is an interface for web applications to access the complete timing information for a resource in a document. And this is also really, really detailed. So think of your style sheet, right? If your style sheet hangs and loads for 5 seconds, maybe you want to know that, because this is render blocking. And this is really delaying the first render. And then there's also the user timing API. And what I want to show you actually is how long does it take to draw 50 unicorns, right? So what you see here is the initial call. And the user timing interface allows developers to create application-specific timestamps that are then part of the browser timeline. For example, maybe in navigation, a single-page app. Maybe you want to know how long it takes to go from A to B. So what you can do then is you can define performance marks. And you see here quantifier start and end, and then you just wrap whatever you're doing there. And then you can define performance measure, and this gives you then the information how long it took from one mark to the other. Then you can get this stuff with window.performance get entries by type mark. So this is the point in time when the first mark happened. And then we have get entries by type measure, which is now the duration here. And you see that the quantify call actually took 6 milliseconds, which more or less fits into my 10 milliseconds budget. But at the end, it's your call if you want to do that. So what we do have in the real user monitoring, so we've got marks, measures, navigation, and resource. And these are available via get entries by type, or get entries by name. But there's one thing wrong with this. This is not actually what we want, because here we're polling for data, we're polling for information, and we have to keep track of all these new metrics that may or may not be there already. So that's not cool. So ready for the next one? We have the performance observer, which is also there. So, and you see a pattern here, right? So you can create a new performance observer. Then you get a list with entries, like that, and then you can do your monitoring. If it's just logging in your console, that's cool. And then you can define of what you want to watch out for. And this way, measurements are pushed towards me. This is really, really good developer experience, because then you can set up this observer in the head of your document, and you're set. When you look at the spec of the performance timeline spec, you will find that developers today are actually encouraged to use the performance observer where possible. That sounds good to me. But then there's also written, maybe new metrics will only be available via the performance observer. So what new metrics are we talking about here? We've got the paint timing metrics, which tells us when something happened on the screen. This is really cool information, right? The first paint means the first rendering, and then there's the first contentful paint, which means any text, non-white canvas, or SVG. This is already shipping in Chrome. Then we have the long task metrics come in, which tell us when some JavaScript operation took longer than 50 milliseconds, right? Think of the smooth scrolling and stuff. You maybe want to know when this took too long. So what I do with my private website is, for example, I just have a performance observer there, and I've got a log mode. So and then I have all these metrics right at my fingertips, and I'm relying on an API, on the Contentful API here, so I also see, hey, how long did this resource take to load? This is really cool information. And let me show you another thing. Is Zalando a thing in Finland?
Yeah.
All right, so let's look at Zalando. What's the most important thing here? I would assume it's maybe the image, but so how hard could it be to figure out when this image is rendered? And it turns out it's actually really hard. So you have to define an onload handler, you have to clear marks, and then set a new mark. So what this basically does is, whatever happens last is the correct value here. So when the script happens last, that's the value, or vice versa. And this is, I think, far away from good developer experience. I would say. So there's a new spec that is may or may not come, but this is really crazy future stuff, which is called Hero Element Timing API, where we maybe can then define, hey, browser, please tell me when this is laid out on the screen. I, as a performance person, am really, really excited about that. And just for the sake of completeness, there's also the Server Timing API, where you can set custom headers in your resources, and these will magically appear in your performance observer. So when you have the use case, that's really, really powerful. If you're interested in all this performance stuff, there was an excellent Google I/O talk, which was called Leveraging the Metrics That Most Affect User Experience. Highly recommend that one. So what's the support? This is how the slide looked yesterday. And we had actually Firefox Quantum released. Evergreen browsers. That's cool, 4 or 5. So the support is actually not that bad. Is this polyfillable? I'm not really sure, because when vendors decide to only push metrics through the performance observer and it's not there, well, the journey is more or less over. Today we can, though, use get entries by type to get the same metrics. So they are available in both worlds today. So unicorns are pretty great. What's better than unicorns?
Mini unicorns.
What? Mini unicorns? And I give you a hint. So I'm from Berlin. This is my favorite stock image of all times. Summer, sunshine, electronic music, and a good open air. I'm really, really happy. So, and to implement what you may or may not know what happens now, I had to cheat a little bit. But let's just assume that the website we're modifying here had some slide up, slide down. Nice. The world is better with a little bit of confetti. So how could I figure out if the elements here open or close? Well, let's check another observer here. So the pattern is the same, right? So you've got the Resize Observer, you have to initialize it, then you get some resize events, and then you can just draw confetti in this case. And I'm just saying then, hey, please watch out and tell me when something changes its size. You might ask yourself, all right, Stefan, but when is this firing? So an observation fires when something is inserted or removed from the DOM, when something gets set to display none or display something else. It is not firing on CSS transforms, though, which is interesting. And with this kind of information, you may have noticed that I actually was cheating a little bit because my implementation was buggy. It was drawing confetti on load. It is drawing confetti on closing, and it's drawing confetti when I resize horizontally. But I think confetti makes me happy, so that was good. When could this be useful? Maybe you have some drag and drop resizable interfaces. So this could be extremely useful to then adjust the scroll position or something like that. And we all wait for element queries, right? Maybe they will happen or not. The element queries, so element queries lets you define on the width of an element what styles you want to have. And there are certainly polyfills out there that will at some point maybe change the Resize Observer. So what's the support of the Resize Observer? Yeah, not so good. Is this polyfillable today? I would say so-so, because to figure out if an element actually changed its size is a very costly operation. So you maybe want to really consider if you want to do that. But I was not really happy about my initial implementation, and I thought, well, maybe let's fix the resize problem, right, and make a proper implementation here. So let's take a step back and let's have a look what we're dealing with. So we're dealing with an initial call, several opening calls, and several closing calls. And what I want to get rid of is the first one and the closing ones. So how would I actually do that? So here we see the callback. To get rid of the first one, what I could do is store a Boolean and toggle that. That works. And how could I get rid of the closing ones? Well, store the last one and then compare. I think this is not really readable, and this is hard to maintain. And this has side effects outside of the event handler. And when you have several entries, this is really, really hard to read and maintain. So let's just, and I have to speed up a little bit because I'm running slightly over time. Let's speed up a little bit. Observables just being in here because it fits the title. So when you think of an array is a sequence in memory, and a observable is actually a sequence over time. They're currently only in spec, and they're talk on its own. So let's just quickly touch them. A collection that arrives over time. And this is an observable implementation. So you initialize a new observable. Then you define a few handlers. And then you subscribe to this observable stream. And when I saw this for the first time, I was like, this is just shifting callbacks around, no? But actually right now, we're dealing with a collection, and which means that we have stuff available which is map, filter, and reduce. And with this, we can write way cleaner code. So let's have a look at the ResizeObserver implementation, and let's just change it to now use Rx. And I changed new observable to observable create. And now we have a collection that arrives over time, which means we now have collection superpowers. I like array operations, by the way. So let's have a look how we could fix the whole problem. So this is what we're dealing with, right? We now have our observable stream. How can we get rid of the first one? Well, skip it. How can we compare if it's opening or closing? Well, there's a function for that in Rx. Cool. How can we now really can get rid of them? Well, filter, right? Array collection operation, really nice. So how can we get rid of these two bubbles now all the time? Well, we have map. And then we can do our stuff. And this is pure functional code. This is code without side effects. This is easy to read, maintainable, and testable. So with this, no confetti on loading, no confetti on closing, and no confetti on horizontal changes. What I want to say is Rx comes with a cost, right? So for implementing our Rx for this is probably not the best use case, but when you're dealing with tons of event, it's kind of worth a try, and then when you measure, you can check. So what we talked about is the intersection observer to figure out if something is visible in the DOM, in the viewport, the mutation observer to react to changes, the performance observer to get notified about performance metrics, and the resize observer to figure out when something changes its size, and observables, just because they fit the title. And what I want to tell you, I work in the front-end industry for 7 years now, and oh boy, so much has changed. And web development is still fun, and probably it's one of the biggest loves in my life, though. But I also know that so much will still change, and it's horribly exhausting, but I love that. And at the end, I think that we live in good times today. And what do you think of when you hear celebration and good times? And that's it.